Hello friends, this is Rani. Today I'll be showing you the sixth experiment of the System Software and Compiler Lab, which is designing an assembler for SIC. So the basic aim, as you can see over here, is to simulate the concept of assembler for simplified instructional computer. And it is written that an assembler is a program that accepts an input, an assembly language program, and produces the machine language equivalent with the information in the loader. So I'll briefly demonstrate the algorithm, then I'll explain the code. So initially we open and read the input file that is given. Next, if the input line has the opcode start, then we start. Since we know that the start operation is the starting of the program, so if there is operand called start, then we initialize the local counter to the operand value. Otherwise, if there is no value, then it is set to 0. Then we write the input line to the intermediate file. Then we do the following steps until the opcode finds end. So once it finds end, it will stop the execution of the program. Next we check the symbol table. If the symbol table is not available, then we enter that symbol into the symbol table, that is the sim tab, along with the memory address in which it is stored. Otherwise an error message will be displayed. So if there is an opcode is present in the op tab, then we increment the LC by 3 and we start writing the location counter and the operation fields. If it is a word, then it is incremented by 3 since a word consists of 3 bytes, and if the opcode is byte, then it is incremented by 1. So reserve word is multiplying by 3. So I'll briefly describe the program. So I have used Java over here. So the main thing that I'm doing, I have imported buffer reader, buffer writer, file not found, file reader, file writer, and the following hash table and scanners. So we have used various exceptions over here. So now you can see that we have used public throws exception. So we are creating a hash table operand and ready the operand table. Then we are creating a hash table with 30 and symbol. Next we are creating a buffer reader, which is reading my this thing over from here, and a buffer writer which is reading this file. So these are the user files that I have created. Next I'll string line and the title. So I'm initializing the local counter and start to 0. Next I'm splitting it. So as we can see, if the line contains start, then I'm splitting it, and if length is 3, then I'm parsing it at the second character by 16. Then I'm starting, else I'll write the line. Else if line contains end, then I'll update it, and if line contains end, and at last else if condition is matched, that is the end, then I'll do length as LC minus start, and LC will be equal to start. Next I'll do BR, I'm closing the various buffer readers and the writers. Next I'm creating a new buffer reader once again and I'm reading it. Then once again I'm creating start. So I'm printing the H followed by the title and converting it to hex to string. At last I will print the entire word. So this is for printing and this is for the T, which is the object code. Next I'm splitting it once again, and here if it's a reserved word, then I'm multiplying it by 3 and I'm parsing it, and if it's a reserved bit, then I'm simply incrementing it, and if it is a word, then I'm incrementing by 3. So this is what we have done over here basically, and at last we are returning the LC. So as you can see over here, then this is the main function, which is a label already exists, and the word I'm incrementing by 3. For the reserved word I'm multiplying it by 2, and I'm simply creating the hash table. So this was the code. Now this is the output, this is the input file over here. Copy start 4000, and this is the starting, this is the ending, and this is the op table text. So next, this is the enter text. So as you can see, it is writing it into the opcode, and thus the concept of assembler has been implemented successfully.